So last time you trained some models. Today we're going to get those models and have them make some predictions, or at least I'm going to show you how to do that. So let's jump back on over to our notebook. So last time we ran our data through our algorithms, and you'll remember we got a bunch of really crappy algorithms that none of these really worked very well. Here, for example, like the F1 score was 0.66, and although the recall seemed really good, that's because of the sparse data that we had, and really that we only got half of what we said was positive. Again, I said two things were positive, which is to say two times school was closed due to the weather. We're not going to worry about whether or not the models we trained above are particularly good models. We're just interested in the mechanics of how we take a model that we have trained and we get it to spit out predictions. Hopefully, when you go through and you do the same process above with different data for a different context, you'll end up getting models that you like. So let's go ahead and work with those models. So this is the same notebook as you were using before. Remember, you need to run the cells above so that you load all the right libraries and you get data into the variables before you start executing the cells that we're going to deal with. So let's assume you've done that, and now you're caught up down here to making predictions. Well, so we have this classifier variable that we're going to define, and we're going to assign to CLF for classifier. We're going to assign the classifier that we made up here that we like the best. So let's assume that I liked this decision tree classifier the best because maybe it was the one that performed the best. And so what I'm going to do is I'm going to go ahead and assign that here. Now, the reason I'm doing that is just so that I don't have to go through and change this and every other time below where I might reference the classifier to be the same classifier as above. I'm just going to say that classifier without a suffix is going to be equal in this case to classifier _2. And then I'm actually going to define a list here where I'm going to include the values of inputs for that I want to test, that I want to get a prediction for. And in this case, remember we had accumulation, precipitation of its accumulation, the minimum and maximum temperatures. And this was, I believe, yesterday's temperature. I may have also, at some point, I think in a different example, I might have included the wind. So depending upon which version you did and what you included, you would need to include a value for each of the features that you ended up training on. So if you ended up having not 4 features, but 5 features, you would need to have 5 features in this list. Okay, for the models above, I trained on 4 features, so we're happy with just 4 features. But again, if you train something different, then you would need to change that accordingly. And all I'm going to do is take this list, assign it to the variable called inputs, and then here's my classifier. That's the model. And there's a method here called predict. And you can see here it has my parenthetical, and I can input something. What I'm going to do is actually a list inside a list. So I'm going to take inputs, put it inside these brackets. And then actually that's going to give me out something that has multiple entries, and I only want the first of those entries. This will become clear when we get further down below why I'm showing only part of those entries. But that's what I'm going to do is I'm going to take a variable called guess. I'm going to take the model, use this predict method, give it the inputs, that's the things I gave, and then it's going to give me out a guess. And then I'm going to print the model's guess. And then if the guess is equal to 0, I'm going to do one thing. If it's not equal to 0, I'm going to do another thing. And we'll break that down here in a second. So let's just run this cell, which I already did. And my model's guess for these variables is that it's going to be 1, which in that case, we were saying school will be closed. So it predicts that school will be closed. And it has a confidence about how confident it is that school will be closed. And it says it has a confidence of 0.8. So 80%, it really thinks that the chance is really 80% that school is going to be closed. Now, what's going on here? Well, if I sort of look at these, I can sort of break down what's going on. I said that I did this thing with this, only the 1, I wanted to get the 0 out of it. Let's see what that looks like if I just take my classifier and this predict statement. Actually, I'm just going to make a new cell here just to sort of explore this. Instead of doing inputs, I'll go ahead and I'll just put in what those input values were. So right there. If I run that, I get an array. And that array is just telling me, it's an array with a value 1 in it, which means yes, right? So closed. And in this case, it means yes, we're going to close schools. I went ahead and I got the value inside the array. That's just getting me the number inside there. So that's why I put that on there. But what's going on here? I have if guess is equal to 0, I'm going to do one thing. If guess is not equal to 0, I'm going to do another thing. Well, this looks very similar to this. This predict method is going to just basically say, based upon the model that you have here and the inputs you have here, it's going to predict either 0 or 1, okay? For the models that we've trained, because the 0 or 1 are the only two outcomes. If you had different outcomes, then it would predict those different outcomes. And so it's going to predict either 0 or 1. And that's all it's going to do. It's just a binary classification, yes or no. Well, I actually can get a little more fine-grained than that. Scikit-learn allows me to get out the prediction for those models that can do a sort of a continuous prediction of probabilities. It can do this. Not every algorithm you would train to do a classification task can do that, but the ones above we chose all do. So I can actually swap out predict for predict probability. And then what it'll do is I'm actually going to take off the end there. I'm just going to do that. And you'll see what it does. It gives me back an array with 2 values in this case. If I had 3 possible predictions, that is to say yes, no, maybe so, then I would see 3 different options here. Here I have just the options of no or yes. And that's what these map to. This is the chance that the thing is not 1. And this is the chance that the thing is 1. Okay, these should sum up to the value 1, right? The chance that one thing's one thing and the other thing's the other thing should add up to be 100%. And so these are just statements about the probability that the thing is a 1 type or the thing is a 0 type, which is to say the answer is either the probability that the answer is 0 or the answer is 1. For our model, for our example of a model we were trying to train on whether or not school would close, this is the chances that school will be open. This is the chances that school will be closed. And you can see if I change these all, what were these? These were accumulation. If I make accumulation 0, let's make the minimum 50 degrees and the maximum 80 degrees, and yesterday's maximum was 70 degrees. I do that, then I can see, yeah, it's almost a 99% chance that school will be open and a very, very small chance that school will be closed. And that's based upon our model above. So what I'm doing here is when I'm printing out, I just wanted to print the guess, the overall guess, and then I wanted to say sort of how confident I was. So if I was guessing 1, I was basically going to pull this second value out. If I guessed 0, then I was going to pull this first value out. And you can see that this bit here is saying get me the either first or the second value, and this bit here is saying get me this thing as opposed to this thing as far as the list goes. So that's what's going on there. So now I could put in information and I could get out predictions. Now the interesting thing is you saw there are these brackets there. So these things we've got these lists, or these we might want to start talking about as an array, right? Some of the outputs, it said it was an array, which is a different data type. And array is basically, it's like a list of lists where everything's a number. We don't need to get into the details of it, but we have arrays all over the place. So we had this array up above of features that we made this above when we were up here. We had the features for testing, right? So features tests. These were basically all the columns for the test data. So the data that we held out because we knew the answers to it. So this is this :3 is just going to give me the first 3 entries in the same way that, like I did the dot head thing on a data frame, it would give me just the first couple. So here's the first 3 entries in that array. You can see the array has, it's a multi-dimensional array, and that it's a list of lists. So here I've got sort of a list here of the values in accumulation, what was it? Minimum, maximum temperatures, and yesterday's temperature for here basically 3 days worth. You can see each of the values inside one of these lists is separated by a comma, and this list itself is separated from this list by a comma. So it's an array of arrays. So it's a list of lists here, basically. And I'm using those terms a little more loosely than I probably should if we were talking in a strict computer science context. But since we haven't gotten that deep into it, hopefully that gives you a sense what they are. So we have these list of lists. And then, as you might have guessed, this predict feature actually can take in an array, right? So it can take in these lists of lists, and it will give me back multiple predictions. So I actually can get all the predictions I can take feature tests, which is, like we just see what feature test would be without looking at the first three. It would be basically all of the features, right, that I had in that testing holdout. So I'd have all of those, and then I can pass them to predict in the same way. So I've got my model that I trained, I'm asking to predict on that array. If I do that, then I get another array here, and this is an array of the answers from predict. And you can see most of the time it says 0, 0, 0, 0. Every once in a while, though, it says 1, close school, close school, close school, okay? And so what we can actually do is, what if we wanted to say, match up these times when school was closed with some value from our features? Let's say I wanted to match it up with accumulation. I wanted to see what the accumulation was on the days when school was, or we're predicting school would be closed. Well, here's another little thing is feature test. I actually can do this :0, and that's actually just going to slice right through that array and show me just the values and effectively what was the first column. Remember, in Python we have 0 index, so 0 means the first. And so what this would do is this would just give me a list of all the accumulations. You can see on most days the accumulation was nothing, but in some days it was quite something. Here was a 10. Here's 4-inch accumulation. And so we can see there are different accumulations on other days. So I can just basically get this array of just the accumulations. And actually I could take that and I could marry it up with this array, right? Because I fed them in such that it's the same order in each. So this first one here corresponds to this first one here, and the second one to the second one, and the third one, and the third one, and so on and so on. So actually, if I just take them and I put them together in 2 columns, then I can match them up. So that's what I've done here. And I'm actually just going to sort of remove this last line here. So we just sort of do it, one bit at a time. So here I'm making a data frame called percentile list. Here's my code for making a data frame, which remember from the wrangling. And I'm going to make a column called accumulation. I'm going to fill it with that first column, this thing here. I'm going to make a column, I'm going to call it prediction. I'm going to fill it with the values of the test, right? This thing here. And that'll produce me a nice data frame where I've got the accumulation and the prediction. If I want to get really clever, though, I can filter that. And I can filter it such that, there we go. I can filter that such that I'm going to do on the prediction, where prediction equals to 1, and it'll just show me all the times where prediction is equal to 1. And then I can see there are my 3 valid times when it was equal to 1, when the accumulation was 10, 4, and 6 inches. Okay, so that just has me being able to answer some questions. The reason I show this to you is because, one, if you've gone through the trouble of training your model, you should be able to get some answers out of it. I could have also done the predictions with the percentages, and I could have gotten the percentages out. But I'm showing this to you particularly because in the final challenge below, you're going to be asked to give a list of the call IDs for which your model predicted take or not take. And in order to do that, you're going to have to take a list like this, which will be sort of take, don't take, and marry it up with those call IDs. And so you can think of those call IDs in the same way as you might think of this list of accumulations, right? It's just something from a data frame, a column from a data frame earlier on. And as long as you keep the order of the data frame the same, you can marry them up. And you can do something like this, and then you'd be able to filter on it to get out what you wanted. A fun thing to realize is if I did this and say I want to just get a list of the accumulations back out, I could, of course, have my percentile list, and I could look at just that accumulations column. So let's say I want a list of just the accumulations. So there are my accumulations, all of them. But let's say I wanted the accumulations where this was this. So I could filter it down and then get the accumulations. There are just my accumulations. And what I actually can do is, let's see if I can remember the syntax. It's to list like that. And then that actually just takes that and nicely prints out a nice list. And I could actually just do a nice copy and paste of that to somewhere. So there is how you can get a list of the accumulations that resulted in a closure. And you might follow something analogous when you were trying to figure out the list of call IDs in your project flow. All right, that's that. Thanks.